Alright, well now we're looking at exercise 3F. We're sketching graphs using the quadratic formula, so these you can't factorise easily, and honestly completing the square is too much effort to be worth it unless you're specifically asked to do so. I'd like to take this moment to remind you, just before we get started, that the general form of the quadratic form is y equals ax squared plus bx plus c. So the number in front of x squared is always a, the number in front of just the x is always b, and the constant term is c. Once we know those, we can find the x-intercepts by just going minus b plus minus the square root of b squared take 4ac all over 2a. So that saves us having to factorise or anything like that to find our x-intercepts, but all the other steps are like normal. So for example, if we have a look at question 3b, the first thing I do is I write down a equals, b equals, and c equals, just to make the rest really automatic. Now here a is the number in front of the x squared term. If there's nothing there, it is 1. B, so that's a. B is the number in front of just the x term. So here it's minus 4. I'm just colour coding these just so it's easier to read later. And c is always the constant term, so here it's positive 5, like that. Okay, we're going to solve these like normal. So the first step, concavity. Is it concave up or down? That's always determined by the number in front of the x squared. Here it's just a 1 in front of the x squared. It's positive, so it's a smiley face. It's concave up. The next step is the y-intercept. So we let x equals 0. With all of these, if it's in general form, it's really easy to see that 0 squared take 4 times 0 plus 5 is just going to come out as 5. It's always the constant term. It always comes out as just c. Okay, and the x-intercept, let y equals 0. So here you might be able to factorise easily. This one we actually could factorise really easily, but we're going to do it using the quadratic formula. So we've got 0 equals x squared take 4x plus 5. So we can say very quickly that x equals minus negative 4 plus minus the square root of negative 4 squared take 4 times 1 times 5. And this is all over 2 times 1. Oh yeah, no, this one we wouldn't have been able to factorise easily. Just ignore me. I forgot that this is a positive 5, not negative 5. Okay, so negative 4 is positive 4 plus minus the square root of, well, negative 4 all squared comes out as positive 16. Take 4 times 1 times 5 is 20. So you should already be able to see what the problem is going to be with this one, because we've got 4 plus minus the square root of negative 4 all over 2. We cannot square root a negative. We cannot square root a negative. So no x-intercepts. This means it all happens above or below the x-axis. Given that we were concave up, it's a smiley face, it's all going to happen above the x-axis. Next step are the axis of symmetry. Now, back in exercise 3D, we added the x-intercepts and divided by 2. Here we can't because there aren't any, so we do minus b over 2a, which some people were doing back in 3D anyway, which was good. So x equals now minus negative 4 over 2 times 1 gives us 4 over 2, which is just 2. Cool. And now the y-coordinate of this, so we sub in x. Okay, so we get y equals 2 squared, take 4 times 2 plus 5. So that's 2 squared, which is 4. Take 8, which is negative 4, plus 5, y equals 1. And now we can sketch. I'm going to sketch next to it. I'm going to go through and just really quickly highlight any pieces of information that we need. So y equals 5, no x-intercepts, axis of symmetry, and the y-coordinate of the turning point. And these are getting lazier and lazier, I think. x, I should have written myself a small note that said sketch. Okay, let's put in our y-intercept. So we're going to do a big old 1, 2, 3, 4, 5. We're going to do a big old point at there. We don't have any x-intercepts. I'm going to mark on my axis of symmetry, which is x equals 2. And my y-coordinate, which is y equals 1. So I can see that I've got a smiley face happening here. So it's going to go through the y-intercept and it's going to be symmetrical. These get worse These get worse. I'm just going to go with that. They're getting worse every time I draw them. Okay, that's 3B. Now let's have a look at, I'd like to do 3D. Is that the, no, 3E I guess is the next one I wanted to do. So, 3E. First step, A equals, B equals, C equals. Here, A is 3, B is positive 6, and C is negative 1. So, first step like normal, concavity. Well, what's the number in front of the x squared? It's 3, so it's a smiley face, it's concave up. Y-intercept. So we let x equal 0. We can very quickly see that y comes out as negative 1 because everything else just disappears. The x-intercept. So here we let y equal 0. So we've got 0 equals 3x squared plus 6x take 1. Now you could factorize this or complete the square. Both are going to be a nightmare. So we're going to use a quadratic formula like we are all the way through this exercise. So we've got x equals minus 6 plus minus the square root of 6 squared, take 4 times 3 times negative 1, all over 2 times 3, yeah? So this comes out as minus 6 plus minus the square root, that looks terrible, whatever, of 6 squared is 36, negative 4 times 3 times negative 1 plus 12. All over 6. This is getting worse. So we've got x equals minus 6 plus minus the square root of 48 on 6. Do we have any square numbers that go into 48? 16 does 3 times. So we've got x equals minus 6 plus minus the square root of, well, that's 16 times 3 over 6. You don't need to do this many steps of working out. Minus 6 plus minus, well, the square root of 16 is 4. So we've got 4 root 3 all over 6. Now I do want to simplify, mostly because it is nice to get a decent surd as your answer so you can be as exact as possible. So, what goes into both negative 6 and 4 root 3? Well, 2 does. So I've got 2 outside of negative 3 plus minus 2 root 3 all over 6. So that's going to give me negative 3 plus minus 2 root 3 over 3, which is the same as negative 1 plus minus 2 root 3 over 3. Okay. Now let's have a look at our axis of symmetry. Actually, no, I'm going to do this further up over here because I'm about to run out of space down the bottom. Okay, axis of symmetry. X equals minus b over 2a. So we have x equals minus 6 over 2 times 3. Well, that's just going to give us x equals negative 1, which, coincidentally, we could have already seen because it's negative 1 plus minus this thing. So negative 1's in the middle of whatever the x-intercepts are. And then we've got our y-coordinate. So we're going to sub in x. So we've got y equals 3 times negative 1 squared plus 6 times negative 1, take 1, which comes out as, well, negative 1 squared is 1, 3 times 1, take 6, take 1, negative 3, take 1, negative 4. Nice. All right, and now we can sketch. Let's give ourselves some nice axes. I like nice axes and I cannot lie. Your other brothers can't deny. Hang on. I'm going to make up something good for that. Okay, x. Let's put on our y-intercept, negative 1. So I know it's going through there. X, -1 plus minus 2 root 3 on 3. Well, I'm gonna say that that's like there and there. I don't have a calculator, so I can't actually tell you what that's approximately. Let's change color. Let's put in our axis of symmetry, which is x equals -1. And let's put in our y coordinate of it, which is y equals -4. Wish I'd made that axis a little longer, no worries. So I'm going to get a smiley face around here. And we're going to wish that I'd drawn that a little better, but that'll do. Okay, let's have a look at one more example, 3i, x squared plus 2x plus 3. So again, a equals 1, b equals 2, c equals 3. We should be able to run through this really quickly. So concave. You know straight away it's concave up. Y-intercept. You know straight away y equals +3. X-intercepts. I'm chucking this straight into my quadratic formula. X equals -2 plus minus the square root of 2 squared, take 4 times 1 times 3 all over 2 times 1, which gives me x equals -2 plus minus square root of 4 take 12 is -8 all over 2, no x-intercepts. Okay, next step is axis of symmetry, which is x equals -b over 2a. I write it every time because I'm still having trouble remembering that. So x equals -2 over 2 times 1, so x is going to come out as -1. Okay, and the y-coordinate of the turning point, y-coord, don't forget we just sub in that value for x, so we've got y equals -1 squared plus 2 times -1 plus 3. -1 squared is 1, take 2, -1 plus 3, y equals 2. And now we're going to sketch. I'm just going to do it over to the right. Sketch. Okay, let me zoom out a bit so I can see all the bits of information I need. We've got no x-intercepts. It's all happening above the x-axis, which is because it's concave up. Let me highlight my relevant bits of information. Y equals that, no x-intercepts. There we go. So y equals 3. X equals -1, so it's going to turn about on that line. Y equals 2, so it's going to turn about on that line, which means we can have a smiley face. And it's going to go up like that and like that. All right, that's sketching parabolas.